All right, finally. It's the hardest part of every presentation is that couple of minutes before it starts and just waiting for the thumbs up from the folks in the backs. And I just got it, so we can jump in and get started. Hello, everybody, and welcome back to the Cisco U Theater. My name is Hank Preston. I'm a principal engineer here in Learning and Certifications, and I'm excited to talk to you all about one of my favorite topics, the evolution of networking and how programmability has affected all of our lives. Right? This is an important topic, I think, and obviously you've all come back to hear me kind of talk about this piece as it goes through. Programmability has been around for a long time, and it's starting to weave its way into every part of network engineering. Automation is starting to show up everywhere. And that's really important because we've never had quite as much time and free time on our hands as network engineers as we have today. I mean, we're all able to come here because it's super calm back at the office, right? Nothing's going on, right? We just sit around twiddling our thumbs all day long, right? It's really not that big of a deal. So it's okay. This is the right time to learn something new. Unfortunately, we all know there's never a right time to learn something new. What we have to do is recognize that we have to find the time. We have to figure out how to avoid the fires in the data center, how to assign somebody else to deal with the RFPs, right? Get out of manning the knock, right? Find the time so that we can do this, right? So that we can sit down and we can focus on figuring out how to learn something new, how to do something better so that hopefully in the future we have less fires and we have less confusion going on. My goal today in this session is to help you with a few ideas and suggestions in your own journey towards the programmable age. But before we jump into today in programmability and automation, let's kind of talk a little bit about what the network is and what it is that we're trying to automate. The network used to be kind of something that we all had in our mind. Many of us may still have this vision of the network in our mind, right? What is a network? It's made up of routers and switches and things we plug into our switches, right? Networks are easy. We can walk into datacom closets, or we can go into the data center and we can like touch the network, right? It's 19 inches wide, 1U, 2U, 3U, so it varies in size. It's teal green and it has Cisco silk screened on the front of it. Unfortunately, the network has never really quite been that simple, and it certainly is not that simple today. It's been evolving and evolving rapidly. The first big change that I remember when it happened was kind of the advent of virtualization and the impact it had on how networks were built. We started to recognize that the network had more layers than that. We now had these things like virtual machines, and virtual machines were connected to virtual switches. Did anybody else have a little bit of like a heartburn or a mini heart attack when you realized that there was switching that was happening and you couldn't reach out and touch it and it didn't say Cisco on the front of it, right? That was nerve-wracking. But we got over that, right? We figured out we can handle the fact that, sure, maybe switching happens in software. We'll negotiate with the virtualization team to figure out who owns that responsibility. We bypassed that one. Great. And then we had the next big problem when the form factor for compute started to change and we had blades. And blades went into blade chassis. And in the back of a blade chassis was something. Maybe it was a switch. Maybe it was an I/O module. But whatever it was another problem because a few things. Once more, it might not have said Cisco on it. And then this was also the harder one for a lot of customers and a lot of engineers, right? It was easy to know who was responsible for something based on who paid for it. But in a blade switch environment, oftentimes the server team would pay for the switch. And so now, like, who owns and operates that? And that was another big challenge we had to deal with. And along the way, we recognized that it was more than just this stuff. We had all of these other things we had to deal with. We had to deal with load balancers, and we had to deal with firewalls, and we had to deal with IPSs. And my favorite part of the stack, DNS, right? How many network engineers are responsible for DNS in your organization? Yeah, I think we should be. Its entire purpose is to take a name and turn it into an IP address. What's more networking than that, right? So these are all part of what we have to do as well. I would have been very content if the world stopped like this, but it didn't, right? We had other advantages or other advances that came. The cloud showed up. And with the cloud came this entire world over here, where at least when I had a virtual machine, I could eventually touch the switch that the traffic went through. But in the cloud, right, is there even a switch? And if there is, I probably can't go find it because it buried someplace in Amazon or Microsoft Should I stop moving? Oh, look at that. All right, I'm gonna bend it away, see if we can fix it. All right, I'll be careful. All right, so in the cloud, things started to shift away and it was farther away from our physical network. Another thing started to show up around the same time, microservices, containers, right? Just around the time we get kind of convinced that we can deal with the fact that there's a virtual switch, right? And we can configure that. Now I have a container connected inside of a Linux VM to a Linux bridge. And we all got scared. What is that? Well, go back to your CCNA studies, right? What is a bridge? It's just a switch. And so now we have another layer of software switches that we have to deal with. And so the evolution of networking has been speeding up on us. The next round started to come through. Overlays started to become realistic, actual overlays that we would deploy. Concepts like software-defined WAN is huge, right? We had lots of topics all week around software-defined WAN. The evolution speeds up, it continues. Now we also have to pay attention to hybrid work. Infrastructure as code, there's some automation, full stack observability. We're all trying to build sources of truth, and buzzwords like SASE are important. There's all these things we have to deal with, and it's a lot. And frankly, for me, this is why automation should be forefront on all of our minds at our organizations, because there's no way that we can do all of this by hand at the CLI, one step at a time. We have to figure out how to scale ourselves. Now, this evolution didn't happen all at once, right? We went through very specific ages in the network. We started back in what I lovingly refer to as the Stone Age, right? We see my good buddy Carl over here, and he's just realized how to break a loop. Spanning tree is born, and we understand how to protect our networks with redundancy. Back in the Stone Age, we had two things we worried about: VLANs and spanning tree. It's been there since the beginning. It's not going anywhere. Love spanning tree. But eventually we did move forward a little bit. We got out of the Stone Age and went into the Middle Ages, right? We earned some more tools. Some new things came at us. The Middle Ages is when we got into kind of the .com era. Our offices started to spread out and we had to connect different offices together. We partnered with service providers and we had to now add in WAN design and optimization for us. We had to learn how to deal with that. Voice over IP. All the old PBXs started to convert into IP pieces, and then we had to learn how to make sure that the voice actually call sounded good. So quality of service came through. Near the tail end of the Middle Ages was a dark time for all of us. It was IP-mageddon. We all remember where we were that day when the last IPv4 address was assigned. Thankfully, every one of your organizations, I have confidence, every one of your organizations buckled down, got rid of the IPv4 addresses, and fully went IPv6, right? We all did it. We had to. No, we didn't. You're all laughing. How did we solve the IP-mageddon? The same way we solve every problem in networking, with NAT. Right? We just convert V4 to V6. Problem solved. That'll be somebody else's issue farther down the road. We came out of that time and we got into the renaissance of networking. The renaissance in networking was like the renaissance in art and industry, a time of exciting new ideas, challenges to the status quo. And this was a good thing. We needed to be challenged, right? We were still just talking about, some of us were still back in the Stone Age. We needed to be pulled forward. And so this is when the concept or the buzzwords of software-defined networking came out, SDN. The architectures, the traditional architecture started to be challenged with ideas around open flow and controllers. Can we break things up a little bit? My favorite part of the Renaissance, and something that has stuck along, is VXLAN. Right? Back in the Stone Age, we had VLANs. We knew we had to segment our networks, even if it just meant we put our printers and our PCs on slightly different networks. But today we need more segments. We needed a new segmentation technology for the future. If there's one thing I've learned at Cisco, I've been here about 14 years. I started in sales, right? We're all about marketing. We're about branding. And how do we invigorate a tried and true piece of technology, right? We relaunch it and we put an X in the product name. That's it, right? VLANs become VXLANs and everything is fine, right? And we continue to segment our network as we go through. The Renaissance went quick. Some of the ideas didn't stick around. Other ones kind of evolved, which brings us to the programmable age today, right? So you're all here listening to me talk. Hopefully you've hit some DevNet sessions. You've heard us talk about APIs, Python. All of these things that are part of what we're doing today to manage our environments, new skills we're learning. And that's fantastic. We're learning how to move forward with us and be ready. But like we didn't get stuck in the Stone Age, right? The future is exciting. There are more things coming at us. I don't know what's coming, but I know that part of it is going to be a little bit scary, right? Artificial intelligence, chat GPT, systems that just decide what to do on their own. I don't know what the future holds for us, but I know that each and every one of us will be there, and we will learn how to evolve ourselves and keep up with those technologies that are there. But it's constantly a lot coming at us, right? What is a network engineer to do? What is Carl to do when all of this is coming at us, right? Carl started back in networking in the Stone Age. He still thinks fondly back when there were just VLANs and spanning tree, right? It was super easy back then, but he's got several years left before he can retire. And now he has to figure out what to do. And so he's got to evolve his engineering skills. Cloud-based networking, container-based networking, hybrid work, they require solid engineering adjustments. Somebody has to learn how to do that. And at the same time, he's being pressed to learn automation frameworks and programmable interfaces and become more automated. I've been talking like this for a while, many years, trying to figure this out for myself. When I first started, right, I felt like I was Carl, and I was like, okay, I got to buckle down, right? We have to do it. It's a transition. I've got to learn it all. I've got to be ready for this. I've learned, I've matured a little bit over that, and I've recognized that we can't do it on our own. No, we're part of a team, right? There are lots of us that are out there. And so if there's one thing I want everybody to realize is that you're not on your own. You don't have to do everything all at once by yourself and be an expert in this and an expert in that and an expert in this. You can kind of diversify a little bit across your team. And so with everybody involved, yes, we have to cover all of this. But if you're going to focus on the core engineering, great. Somebody else on your team might focus on the automation side, right? If you really want to dive into cloud, that's awesome. Like, it's too much to expect us all to do everything all at once. This idea of kind of specialization, moving ourselves down a path of what we're trying to learn, is something that we've recognized here at Cisco and in learning and certifications. And we've started to evolve our certification model. A few years ago, we kind of branched off. We've traditionally had engineering certifications, CCNA, CCNP, CCIE, focused on how do we design, architect, scalable, secure, reliable networks. That skill is still very valid. All of the specific skills needed are continuing to evolve. And so we're updating those blueprints, the tests, the training. Now we also have engineers that want to focus on software and automation, where their primary day job is the automation side of it, right? So we have our DevNet certifications there. And security is continuing to evolve on its own, right? There's different ways to approach security. There's security folks that are focused on engineering, designing the security, building the firewalls, building the platforms. And now we have this up and coming side of cyber ops, security event detection, threat analysis, right? And so we've also got certifications focused on that area. Now, occasionally we have those unicorn engineers that want to do it all, which is great. If you want to pick up across the board, that's fantastic, well balanced. But more likely, you'll pick different parts in your career to focus. And we've got certifications and training that can help you kind of dive in those directions as they happen. All right, so let's go back to this, right? We're all on this evolution. We're trying to figure out how do we bring programmability and automation into our organizations. And so we'll go back to Carl and a little bit of a story time. This is one of my favorite cartoons because I have a mental image, like this idea of what this is. This is Carl in the lunchroom on a Monday after a change window that went okay, right? Our change windows typically go okay. They don't go perfect, but they go okay. And so he's here and he's hanging out and he's got his hot dog on a fork and he's thinking through and he's all right, planning, how are we going to do this better next year? Because we can only do changes like once a year. So he's planning ahead for next year. And he looks clear across the cafeteria and he sees something that just boggles his mind. He sees some of the software DevOps guys and he's kind of like, that's different, right? I don't quite understand what's going on there. There's a few things that catch his eye. First and foremost is, how are they allowed to wear shorts, right? That doesn't align to dress code in the organization, right? Shorts, backwards hats. He also kind of spots the laptop covered in stickers, and he's got a buddy that's on the laptop team, and he's like, that guy, Bob, he's going to be mad when that laptop comes back in. Do you know how hard it is to get stickers off? But the biggest thing he notices, right, he's got security on the mind after the change window, and he's like, how in the heck did they sneak this guy into the cafeteria, right? Did they get him a badge? Is he a visitor? Did they do a background check? Because that is just weird. But the other thing he notices is look at their faces, right? They're happy. They're smiling. They like what's going on. And he says, okay, all of the other weird stuff aside, maybe there's something we can learn from what's going on in the DevOps world. The DevOps group, the software engineering teams, right? They have their thing, and they've been going through their own evolution over the last several years. Then we've got us on the network operations side. Traditionally, we look at us and we're quite different. Right? What are we focused on as network engineers? Acceptable risk. Our primary goal at our organizations is to make sure the network is up all of the time. And so our focus on anything we do is acceptable risk. We want to make sure things stay safe. Whereas the DevOps team, the software folks, right? What are they trying to do? They're trying to innovate for the business. They're trying to get new ideas out there, bring customers in, make sure your competitors don't do something before you do. And so they're focused on speed. How do they get speed? Well, they get speed through pipelines, through automation, through all of this stuff we've heard. How do we handle acceptable risk? Well, we handle it the way we've been doing it since the Stone Age, right? We do everything one at a time, sequential. We do it manually, right? We rely on our CLIs and our UIs and our show commands, and we just really focus in one at a time. I'm going to break something to everybody right now, right? The best way to manage acceptable risk is not to make mistakes, right? Who makes mistakes? I make mistakes, right? We make mistakes. Human error is the biggest thing that goes through. And so if really what we want to have is around acceptable risk, which is a good thing to continue to focus on, we have to figure out how to move forward and adopt things like automation and pipelines. I got a good buddy of mine at Cisco that likes to talk about his days back when he worked at a large service provider. And his team would have to go do massive changes across many, many customers, hundreds of routers. And he would say the first time they did it, they would make sure that the design was correct, right? They would test it, they'd make sure it was good. Every time after that, it was either an exercise in copy and paste, or they were typing it and things would go wrong, right? So we still want to focus on doing things right, but then, let the automation take over. Figure out how to leverage the tools and things that the automation folks have been doing to make our life better. This is what I like to refer to as NetDevOps. It's bringing DevOps concepts into networking. And if we can do this successfully, we have a lot to gain. Our networks stop becoming like rainbows of color where everything is different, right? I like the idea that some things are unique, but I don't want every switch and router in my environment to be different, right? That's hard to manage and maintain. So I want boring blue everywhere. I also want, with automation, the ability to make changes in the environment, see if they're good, and then make sure everything eventually ends up back at that same line, consistency. And I also want the parallel processing that comes from automation. Push these changes out everywhere. This move to automation and NetDevOps and programmability is a massive change. The tools, the technologies, the culture, the things we think about. And like any large change, we have to figure out how to approach it. And so at least in the States, we have this saying, if you've got something big to do, how do you eat an elephant, right? That's a massive thing to do. And the answer is always the same, one bite at a time, right? You've got to figure out where to pick into it. Because what we're stuck with right now in many of our organizations is a culture and a cycle of fear, right? We're afraid of our networks. Or maybe if we're not afraid of our networks, our organization is afraid of what we might do to our networks. And so when a change comes up, the possibility of change comes through, it's seen as a huge risk, right? They don't happen often. And so when we do get a chance, we have to do everything possible in that one change window. And so they're huge, they're complicated changes. We're not practiced. We only do this once or twice a year. And so we're worried. Our bosses are worried. Our bosses' bosses are worried. The application team is worried. Your Cisco account manager is worried, right? Everybody's worried about this change. And we all get together on a conference call and listen as that one engineer has to like type in the commands one at a time. And eventually something goes wrong. Not a big problem. More often than not, it's something like this. The engineer's typing something in and they go, huh. And as soon as that word comes out, every application guy is like, what broke, what broke, what broke, what broke? And it's immediately seen as a big problem, where probably it just took maybe 3 pings longer than expected for the network to come back, right? But because of that, everybody just assumes, right? It reinforces something went wrong, it was bad, and we're stuck in the cycle. We have to break out of this. We have to become comfortable with change. We need to get our organizations comfortable with change, and so that we can do regular changes, tiny changes, changes that we learn how to test in advance, and we become good at it. But this is not something that you can go home on Friday after one change window and be like, next time, we're doing it better, right? It's a baby steps. We have to do this a bit at a time. We have to pick use cases that we can kind of inject and try to learn how to do this faster, how to use automation and new ideas around these things. And so what you have to sit down and say is, okay, well, what thing am I going to do? How am I going to start? These are the use cases that we can consider. I break use cases down into 3 basic chunks, right? We have deployment activities, the day 0 stuff, zero touch provisioning, rolling out new gear, maybe even software management. Then we have configuration management, right? The loading of changes, adding new VLANs, updating ACLs, changing routing protocols, spinning up a new VPN, right? Any of that stuff, just configuration management. And then our third bucket, health and performance monitoring, making sure the network is healthy and operating successfully. Everybody I talk to, right, where they want to start is here, configuration management. What do we want to do? What's the hello world for network automation, right? It's spinning up VLANs as fast as you possibly can. That's great. It's an important skill, but I highly encourage everybody not to see that as the first place to truly try to change what you do. No, go here. Go to health and performance monitoring types of use cases for 2 very important reasons. Number 1, every day we come into our office, we want to make sure the network is healthy. Very few organizations, every day they go into the office, they have to spin up 1,000 VLANs, right? That's an occasional thing to do. And so the work we do around health and performance monitoring is valuable every single day. A subpoint to that is if we do this really well, we free up time so that we can focus elsewhere. The second major reason I tell people to start on health and performance monitoring is the vast majority of what we do in those use cases are read-only activities to the network, which inherently makes them safer. Not safe, safer. Safer. That means that when we're learning how to use Python, Ansible, APIs, Terraform, whatever you're doing, right, it's less likely you're going to cause a problem in the network. So we learn those skills on a safer activity. And then eventually, the time comes to move towards configuration management. Then you have to decide, what are we going to go after? And I know you're like, all right, now's the time I can spin up 1,000 VLANs, right? VLANs have been around since the Stone Age. I want to spin them up fast. Hold on, right? We'll get to that. Where you want to start is on something that is very, very minor in configuration management. Something that when you do it wrong, nobody should notice. My go-to for years has been start with SNMP community string rotation. Why? It's something we're supposed to do all the time. It's something that most of us don't do nearly as often as we're supposed to. And it's also something that if we do it poorly, if we make a mistake, we're probably only affecting ourselves, right? That is a great place to start with configuration management, and then move onwards towards things that get slightly riskier. After SNMP, do NTP. Eventually, maybe tackle TACX secret rotation. That one's super dangerous. But the value of that one is that when you break it, it's still probably just you that is suffering. Eventually, you can get to VLANs and ACLs and all those other things. Now, all that said, right, where do we want to get to? What's the dream of NetDevOps? It's like a fully automated pipeline around what we're trying to accomplish. And so this is what it might look like when you get to that point, right? So we've got Carl. He's been doing this for a while. He's trying to figure it out. But as you can see from his face, he's still a little uneasy, but that's okay. We like new things. And so he sits down and he opens up and creates a new branch inside of his repository for this change that he's been asked to do. On his laptop, he uses whatever configuration management tool is relevant, maybe Ansible, Terraform, NSO, just Python, doesn't matter. But he makes those changes, right? He does what he thinks he's supposed to do, and then he tests that configuration locally. There's lots of ways we can test that. You can run virtual versions of switches and routers and firewalls on a laptop, right? You can use simulation tools that simulate control plane like we have in NSO. Right? There's lots of options to test locally, small testing. Once Carl's convinced that he thinks he has it right, well, great. We'll push those changes up into our automation solution. And here GitLab says, all right, let's test and see if Carl did this correctly. We spin up a test network using Cisco modeling labs that looks and feels very similar to production. We spin it up for the test. We then use our automation tools to push everything out, not just Carl's change, everything. And then we can run tests using something like PyATS to say, okay, is the network really working, right? Do I have the routing neighbors that do I expect? Did I get LACP port channels where I thought I was going to get them, right? All those tests, make sure things look good. If everything looks good, fantastic. We'll send a notification back to Carl and he can move on to something else. If something doesn't come back okay, the notification goes back with details. Hey, Carl, this test failed. And then we just repeat the loop again, right? Until we get it right. This is the approach. This is where we're trying to get to. This is not something that you do all at once, right? We have to, just like it's another elephant, we got to have bites out of this. You'll pick a spot to start and then you'll build your way around. Thankfully, Cisco and DevNet and Learning and Certifications and Cisco U is trying to help everybody build the skills to start biting away at the elephant and figure out what's in place. And so if you haven't so far, I encourage everybody to go sign up for Cisco U. We've got a network automation fundamentals track in the free tier that'll allow you to dive in and learn the basics of Python. That went faster than I thought it was going to. Learn the basics of Python. Learn what's going on in these areas. Experiment with the tools that are out there. Lots of capabilities to dive in. If you're also trying to, there must be an auto forward on that slide that I didn't realize. If you're also trying to figure out how to get a simulation, a test network, something very, very important, investigate Cisco modeling labs. We have some of our developers actually just back there that they'll show you and demonstrate. We also have a deal going on this week for a discount of 25% off of CML if you want to dive into that. Take advantage of the opportunity to add new things into your toolbox, right? All right, so with that, there we go. I'll just let it go forward. Hopefully this is kind of giving you some ideas on how you can approach bringing programmability into your own environments. But this is a journey. As I mentioned, we're not alone, right? I'm here, your fellow network engineers are here, everybody at Cisco's here, so stay in touch. If you've got questions, reach out. I love helping engineers figure out where to go. My contact information is there. I also love to kind of like talk or tell stories, and so follow me up on blogs for all sorts of interesting ways to kind of tackle with what's out there. All right, with that, I am done with my session today. I want to thank all of you for coming and spending a little bit of time going on this journey with me and Carl. We've been doing this for a while, but we're still very excited and passionate about what programmability and automation has to offer each one of us as engineers. And so on behalf of everybody here at Cisco U, thank you for joining. We're not done for the day. We've got a few more sessions still lined up, and I hope you all enjoy the rest